All right, so this warm-up is basically covering that piecewise function and also the part where you're evaluating. So first it says graph the function, and then it says evaluate at x equals 1 and x equals 3. So it kind of blends the 2 days together. So if I asked you to graph this function, and I got y equals 1/2 x squared plus 2 as my first graph, what do I expect that graph to look like? What happens if there's an x squared in there? It's a parabola, okay? What kind of transformations are happening with this parabola? It's a vertical compression, and what's the plus 2? Up 2, okay? So I can kind of guesstimate where it's going. I can get it kind of an idea of where it's going, but I don't know how wide it's going to be until I plot those points. So I would recommend you plot the points here. So if x is less than or equal to 2, that means I'm starting at 2, and then I'm going to go less than 2. And since this is going onto the left axis, I would actually go further. So I don't have to do every point in between, but I would make sure that I covered enough to know what's happening on that curve to the left. What? I'm plugged in 1/2, 2 squared plus 2, 1/2 of 4, plus 2, which is 2 plus 2, I get 4. If I plug in 1, 1/2, 1 squared plus 2, 1/2 plus 2, 2.5. If I plug in 0, I get 2. If I plug in -1, I get 2.5. So if I were to plot those points instead of the estimation that's here, I'll do it in blue so you can see it. All right, so 2 is 4. 2 was 4, so we were close but not 100% accurate. 1 and 2.5. 0 and 2, -1 and 2.5. So I know my curve is looking something like this. And then it's less than or equal to, which means this 2 point is going to stay solid. With me so far? Erase this original line. Okay, then the second part of this piecewise function is y equals 1/2 x plus 3. What kind of line is that? Wait, what kind of graph is that? It's a line, right? So I can start by going up to 3 and going up 1 and over 2, up 1 over 2. Draw my line. And then only keep what's to the right of it. This time it would be an open dot here pointing right. Or I could also plot those points starting at 2 and going on to positive infinity. So I would have picked like 2, 3, 4 maybe, and gone that way. Questions on the graphing part of it. So lines, I would say use slope, intercept, and erase. But with your parabolas, you're probably going to want to plot your points, unless you know exactly where they're going. All right, then this says evaluate at x equals 1 and x equals 3. So if x equals 1, which function am I picking, the top one or the bottom one? Top. So this would be 1/2 times 1 squared. Oh, I already did it, which is 2.5. So f of 1 would equal 2.5. If x is 3, am I picking the top one or the bottom one? Bottom one. So this time I have to do 1/2, 3 plus 3, which is 3 over 2 plus 3, or 1.5 plus 3, which was 4.5. So f of 3 would be 4.5. Or 9/2 if you wanted to write it that way. It doesn't matter. Questions on any of it? So obviously on the quiz there will be the graphing component of the piecewise function mixed with evaluating the function at that point. All right, so 6.5 is called operations with functions. So operations are like adding, subtracting, multiplying, dividing, and then there's something called a composite function. So we're going to do all of these with functions or equations that have variables in them. That's the only difference, okay? So you can perform operations on functions in much the same way that you would perform operations on numbers or expressions. This is combining like terms, okay? Or multiplying binomials, that kind of thing. All right, so just like you do with your every other expression you've ever dealt with or numbers, you can add, subtract, multiply, or divide the functions by operating on the rules, basically combining like terms or multiplying single terms, that kind of thing. So addition of two functions, if I have f plus g of x, then I would take whatever f of x is and add it to g of x and combine my like terms. Subtraction, f minus g of x, I would do f of x, whatever that is, subtract from it g of x. Multiplication, so it would be written like that, f and g right next to each other. That means a multiplication. I would take whatever f of x is and multiply it times whatever g of x is. And then division is f over g. So whatever goes in the top, obviously whatever comes first goes in the top, and then whatever's in the bottom. When you're doing division, you want to pay attention to restrictions, meaning whatever's in the bottom can't be 0, because then what happens? What happens when you divide by 0? Undefined. Okay, so the problems will look like this. So you're given an f of x and a g of x, and then it's asking you to perform whatever it asks you to do. So in this case, A is asking you to do f plus g of x, which means I'm going to take f of x, and I'm going to add to it g of x. F of x is 4x squared plus 3x minus 1, and I'm going to add to it g of x, which is 6x plus 2. And then I just combine my like terms. So there's only one x squared, which means the 4x squared gets left by itself. There's two x's, 3x and a positive 6x. If I add those two together, I get what? 9x. And then there's a negative 1 and a positive 2, which would give me positive 1. That's it. Just combine your like terms. Questions on that one? Okay, then I get f minus g of x, which is f of x minus g of x. So I take the f of x, which is here, 4x squared plus 3x minus 1, and I subtract from it g of x, which is 6x plus 2. So the most common mistake made here is not distributing this negative to both terms. Be really careful. Make sure it goes to both. So this would be 4x squared plus 3x minus 1 minus 6x minus 2, which becomes 4x squared minus 3x minus 3. Okay, when you're dividing functions, make sure you pay attention to domain restrictions, which is that at the bottom, remember, whatever's in the bottom can't be equal to 0. So if I ended up writing like 2x plus 1 over x minus 3, then whatever's in the bottom cannot equal 0, which means x cannot equal 3. That's what it means by a domain restriction. Okay, so now, given f of x is 6x squared minus x minus 12, and g of x is 2x minus 3, find a f times g. So this is f of x times g of x, which is 6x squared minus x minus 12 times 2x minus 3. And then the fun begins, because you get to FOIL this out, right? So I get to multiply 6x squared by 2x, and then by negative 3. So 12x to the third minus 18x squared. And then I multiply negative x times both of them. Negative x times 2x is negative 2x squared. Negative x times negative 3 is positive 3x. And then I multiply the last one. Negative 12 times 2x, negative 24x. Negative 12 times negative 3, positive 36. With me so far? Now combine all my like terms. So there's only one x cubed. There are 2x squared. There are 2x. single constant that's by itself. Mm-hmm.
So we're just.
Yep. For now. Questions? All right, and then B says divide f divided by g. So obviously the order is important. The f has to go in the top, and the g has to go in the bottom. There you go. So as soon as you put something with an x in the bottom, you've got to test for your domain restriction. So I would say that 2x minus 3 cannot equal 0, 2x cannot equal 3, and x cannot equal 3 over 2. So this is my answer, but my restriction is that x cannot equal 3 over 2. The part that we just did, whatever's in that bottom, set it not equal to 0, and then treat it as though it was equal to 0, except at the end it's just, it can't be that. So solve it for x. So we add the 3, divide by 2, and then we get the x by itself. Just the bottom, because the top can be 0. 0 divided by a number is still 0, which is a number. But when it's in the bottom, it's undefined. Sometimes it will and sometimes it won't. So I could try to factor this. So negative 72, and then negative 9, positive 8. So this would be 6x squared minus 9x plus 8x minus 12. Factor by grouping.
Wait, but what do you factor?
I'm factoring the top. So instead of dividing, you can factor it and see if it's even factorable. 2x minus 3.
Doesn't, like, I thought if you have the same variable fraction, doesn't it like subtract?
Oops, there's a B. No, you can't cancel it out. It's got to cancel completely. So whatever, when I factor the top, I get this. The only way to cancel from top and bottom is if the entire expression is the same. If it's multiplication, you can cancel. If it said 4x over 3x squared, I can cancel the x's. But as soon as you see a plus or minus involved in these, the entire expression would have to be canceled. So when you see something like that, you would factor it out like we just did, and then because these are the same, I can cancel them out, and I would just get 3x plus 4.
So what's the answer then? Is it that?
This is the answer, and then this is my restriction.
So we have to find both of those.
Yeah.
Okay.
Sometimes it'll be factorable in a divide, and sometimes it won't. Sometimes you'll get things like 2x minus 1 over x plus 4, and that's it, you're done. But in this case, if you've got a squared in the top, usually you need to factor it,
Got it. Okay.
and then see if it simplifies.
Okay.
Oh, so we can keep going?
Because you have to do, yeah. And you have to do the restriction before you cancel it out. So you want to do the restriction at the beginning. So there's another one on the other side, you can try it. All right, so you try this one. So same concept, right? It gives you an f of x, it gives you a g of x, and then a is asking you to multiply them, and g is asking you to divide them. Make sure you pay attention to the order of the division. This time the g is in the top and the f is in the bottom. All right, so the first one is multiplication, right? So I'm going to do f of x times g of x, which is x plus 2 times x squared minus 4, and then FOIL it out. So the first ones get multiplied. I'd get x to the third, the outer, negative 4x, the inner, positive 2x squared, and the last, negative 8. And then you just want to make a habit of putting it in decreasing degree order. So it would start with x to the third plus 2x squared minus 4x minus 8. Raise your hand if you got it right. Okay, good. All right, then the next one is g over f of x. So this is g of x over f of x. G is x squared minus 4. That goes in the top. X plus 2 goes in the bottom. So before we simplify this, we want to identify the restriction. What can't x equal this time? Good. Can't equal negative 2, right? Because it would make that bottom 0. Now, can I factor the top? What would the top look like if it was factored? Good. x plus 2x minus 2, it's a difference of 2 squares, over x plus 2, and then the x plus 2's cancel, and I'm left with just x minus 2. So x minus 2 is what g of f, or g over f of x would be, but the restriction is that it cannot equal negative 2. Wait, let's start that. Should be minus. Questions so far? Okay, so I'm going to stop there.